Thamarai, we'll continue with this trigonometric functions, ratios and their identities. As we call this sin theta, cos theta and tan theta, all are said to be the circular functions. So why it is said to be a circular function? See, this is a circle whose interior angle, the total angle would be 360 degree, and this is in the first quadrant, second quadrant, third and fourth. Okay, each would be of 90 degree. And okay, so let us come to the other things. See, any coordinate, suppose if it is lying in the first coordinate, a point lying in the first coordinate can be denoted with x and y, because this circle can be denoted with two dimensions or two axes, x and y. Right. So here, this x takes r cos theta, where this r is going to be the radius of the circle. Similarly here, the y is said to be r into sin theta. How it arrived? So last class we have seen the relationship, right? Sin theta is equal to y by r. In place, y is equal to r sin theta. So this is how we got this one. Similarly, the cos theta, that is equal to x by r. In place, we get x is equal to r into cos theta just by cross multiplying. So this is how we got these relations. So that means that this sin and cos can be denoted on the circumference of the circle. That is, it is used to denote the points or the coordinates of a circle, the circumference of a circle. So this is how we arrange this. Okay, now what are the identities? Okay, and as I already told you, what is tan theta? That is equal to sin theta by cos theta. So this is also we have seen the last class. Right. Now coming to the identities, we have three basic identities, which is very important. And the first identity is sin square theta plus cos square theta, that is equal to 1. So we have a small proof how we arrived at this. See, there is what is if you take the left hand side, what is sine? That is y by r. Okay, so sine square means y by r the whole square, plus cos square. So cos we denote by x by r. Okay, so in the last class we have seen. So this is a right angled triangle where this is denoted by x, this is denoted by y, and the hypotenuse, which is opposite to this 90 degree, is denoted by r. Right. In this case, how we can write? So this is y square by r square plus x square by r square. Right. So normally if you take r square, then this becomes x square plus y square. And using the Pythagoras theorem, so this r takes the form root of x square plus y square. So that means that this x square plus y square can be written as r square. So these two will get cancelled and finally it will arrive as 1. Okay, so from this what we can write is sin square theta equal to 1 minus cos square theta, and this cos square theta can be written as 1 by sin square theta. So these are the various forms which we arrived with the first identity, because sometimes we may need to write sine in terms of cos or cos in terms of sine. In that case you can use these two. Okay, and what about the second identity we have? That is 1 plus tan square theta is equal to secant square theta. So from which we can write tan square theta is equal to secant square theta minus 1, or secant square theta, when you bring this tan square to that side, that becomes minus tan square theta, that is equal to 1. So this can also be proved similar to that of this first identity, but it is not required. You just understand these three results. Okay, and the third one, that is 1 plus cot square theta is equal to cosecant square theta. So similar way you can write these things like cot square theta in terms of cosecant as cosecant square theta minus 1, bringing this 1 on this side. Or we can write keeping this cosecant square theta on the right hand side, you just bring this cot square theta to that side. So cot square theta then becomes 1. Right? So you have to understand all, you have to remember all these identities, so which would be very helpful for you to solve more problems in future. And next thing is, what we are going to say is the trigonometric values. Okay, so for 360 degrees, we need to know what are the values at least basic in our requirements, and that would be very useful. And even the values are can be found using calculator or logbook, but we need to remember all these things. So basically, so I'll take this theta and the values for sine, cos, tan, then cot, cosecant, and the secant. I'm just using the order, don't worry about it. So we'll start with the 0 degree, 30 degree, 45 degree, 60, 90, 180 and 360. So you may ask, sir, why is there in between the values? How we can do, for example, for an angle of 135. So suppose if it is 135, we can write this as 190 plus 45. Similarly, if it is say 225, we can write 180 plus 45. If it is 330 degree, we can write this as 360 minus 30. Okay, so how to find the values of these things that we will see in the upcoming classes. Now, our aim is to remember the values of these trigonometric ratios, at least for these angles. Okay, and here so sine 0 is 0, sine 30 that is it is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1, and the sine 180 becomes again 0, and the sine 360 also 0. Then cos it will be 1. So you can just reverse the order from 90 to 0 degree of the sine. You can obtain this cos theta. So here cos 0 is 1 and cos 30 is root 3 by 2. Again cos 45 takes the same value of sine 45, and cos 60 is 1 by 2, cos 90 is 0, and cos 180 is minus 1, and cos 360 again it becomes plus 1. Then similarly tan. Okay, so if you take tan 0 it is 0, tan 30 is 1 by root 3, tan 45 takes the value 1, tan 60 is root 3, tan 90 is infinity, right? And tan 180 is 0, tan 360 again it becomes 0. So once you come to know, right, these functions, then automatically you can find out the values for the other three functions. Say cot 0 means it is 1 by tan 0. What is 1 by tan 0? That is 1 by 0. Again it becomes infinity. That means that the reciprocal of all these things will be the value for this cot. So cot 0 will become infinity. And the reciprocal of 1 by 3 becomes the cot 30. That is cot 30 is 1 by tan 30. So the reciprocal of 1 by root 3 is root 3. Again the reciprocal of 1 is 1. Reciprocal of root 3 is 1 by root 3. Again, if you find out the reciprocal of infinity, it becomes 0. Then 1 by 0, that becomes infinity. Here also 1 by 0, it becomes infinity. Now coming to this cosecant. So you know what is the relationship between the cosecant and other the first three relations, right? Cosecant is nothing but the reciprocal of sine theta. So cosecant 0 means sine 0's reciprocal, that becomes infinity. Then reciprocal of 1 by 2 is 2, and for finding the cosecant 45, the reciprocal of this 1 by root 2, that becomes root 2. Then reciprocal of this cosecant 60 is nothing but the reciprocal of sine 60, that becomes 2 by root 3. Then reciprocal of cosecant 90 is nothing but reciprocal of sin 90, that is 1 by 1, again it is going to be 1. Then the reciprocal of 0 is infinity, and again this becomes infinity. Now we have found out this one. Next, for secant, we have to take the reciprocal of cos, right? So for secant 0, the reciprocal of 1 is 1, and that is the reciprocal of this cos 30 is going to be the secant 30 value. Then reciprocal of this root 3 by 2, that becomes 2 by root 3. Again the reciprocal of 1 by root 3 is root 2. Then again it takes the value 2. Here the reciprocal of this cos 90 would be secant 90. So cos 90 takes value 0. So it becomes infinity. 1 by 0 is infinity. And again 1 by minus 1, it is going to be minus 1 here. Then 1 by 1, that is going to be 1 here. So I hope you are clearly understood the trigonometric values. Right. Now we have to remember this, because this is very important. You have to remember forever till you complete your degree at least. Right. Because unknowingly or knowingly this will come then and there. Right. And find out the angles of that is the angles in between 0 to 90 or 30 or 60 or even 360 degree, right? Like 225 degree, 272, 85 degree or any other things, right? All those things we will see how we can find out. So we use the quadrant rule where, so this is, we'll start with the positive x-axis here. So this positive x-axis starts with the 0 degree, because we always measure the angle in counterclockwise. That is why it is 0 to 90, again 90 to 180 degree, then 180 to 270 degree. Again after one revolution this becomes 360 degree. Okay? And we call this as a first quadrant, this is second quadrant, this is third, and this one as fourth. Okay. How you denote this? See, always this first quadrant is plus theta, because it is on the positive y-axis. Okay, we call this as y minus y, and this is minus x. Then that side is the plus x. And similarly here, whatever the angle we denote, okay, that would be considered as a minus theta. This is in general, but in our quadrant rule, what we do, any angle which lies, suppose if a point lies here, and the angle suspended by this point is going to be theta, then what about this theta? This theta would be less than 90 degree, right? So that is why how I am denoting this quadrant with the angle as 90 minus theta. Okay, so any angle which is just above this 90 degree, so this is going to be acute and this is going to be obtuse, right? So the angle lying between 90 to 180 is obtuse, and then the 0 to 90 degree is said to be acute angle. That in your lower classes you have studied. So if any point lies here, it is more than that of 90. So what we denote this angle as 90 plus theta, or it is less than 180. So 180 minus theta. Right? Suppose I have a point here, and the angle is 120 degree, for example. This definitely this 180 to 120 degree would be less than 180, or greater than this 90. So what would be this angle? So 160 minus, that is 180 minus 60, that is going to be 120 degree. So this is how we just denote the angles of the second quadrant. Similarly for third quadrant, you yourselves can easily say that is 180 plus theta, or we can say this as 270 minus theta. Then above which the fourth quadrant, it would be 270 plus theta or 360 minus theta. Again, for one revolution, after one revolution, again it will enter into the first quadrant where the angle would be 360 plus. So that is why we are just denoting this angle with the 360 plus theta. So in short, we are denoting this as plus theta. Why? Because for each 360 degree of revolution or rotations, right, the trigonometric values will be repeated, right? Like if it is a sine, for example, sine 30 is equal to 1 by 2, then what is the sine 390? Again, this can be written into 360 plus 30, where again this is going to be sine 30, that is 1 by 2. So not only for sine, for cos or anything else, the same thing is going to be. So for example, if it is cos 270 degree, so that is what is cos 270 degree? That is going to be 0. Right? Suppose I take some 360 degree plus. So what happens here? Cos of 270 plus 360, that is going to be 630 degree, for example. So if it is cos 360 degree, then this cos 270 degree will also have the same value for, that is cos 630 degree. So this is what we have to infer from this. Why for every 360 degree is repeated? Okay, because it always enter again, it's the same position after 360 degree. Suppose if the point is here, then it is again after 360 degree, it is again coming to the same point. That is, it repeats, it's the same position, right? So that is why these trigonometric functions are called periodic functions. So what do you mean by periodic function? When the functions repeats, or the functions repeat itself after a time period, say t, then those functions are called as, that is, periodic functions. So what is the time period for this trigonometric function? Here this is equal to 360 degree, or we can say in radians 2 pi radians, right? So this actually in trigonometry we have to be clear on one thing, that is, either the angle can be denoted in degrees or the angle can be denoted in radians. Even if you use the calculator, according to this radian and degrees, you have different modes that you can see later. And here, this 90 degree means it is pi by 2. Why? Because we take this pi as 180 degree, right? So numerically, it is in radians 22 by 7. Okay? So in angle, this is 180 degree. So pi by 2, that is what you will say 90 degree. Why? Because it is 180 degree, pi takes 180 degree and divided by 2 means 90 degree. Right? So this is how. This 180 can be, it is equal to pi, and 270 can be 3 pi by 2. Again, this 360 then goes to be 2 times of 180 degree, that is 2 pi radian. Okay? So these are the basics you have. You have to remember before we enter completely into the trigonometric, solving the trigonometric problems, right? I hope you have understood up to this. Now, what are the things? Why we are here denoting all this and dividing this into different quadrants, and why we are saying the quadrants? In terms of these various angles. Why? Because here, the first quadrant, both the trigonometric functions, say always we denote cos first and the sine next, because it's x and the y axis, right? So here, both the cos and the sine takes positive value. That means that all the functions, if sine and the cos are positive, definitely tan theta would also be positive, because the tan is nothing but sine by cos. So both are positive means again it's positive. And what about its reciprocals? Secant, cosecant, and cot, everything would be the reciprocal of these trigonometric functions. When these trigonometric functions or ratios are positive, definitely their reciprocals will also be positive. Okay, so this is what we have to infer from this. So it is enough to consider only the c and s, that is cos and sine, its function along this x-axis and y-axis. Right. So here, why it is plus? In the x-axis, it is on the positive x-axis side, and this y is also the positive, because this quadrant lies between positive x-axis and the positive y-axis. That is why it is plus, comma, plus. If you take this second quadrant, it is lying on the negative x-axis, right? So we denote this as minus on the x-axis, but it lies between the positive y-axis. So minus plus is the sign which we give in this second quadrant. And the third quadrant, it is both the x-axis and the y-axis are negative, so we can denote this third quadrant with the minus comma minus. This is minus comma plus, right? And coming to this, you can easily say, so this quadrant, fourth quadrant lies in between positive x-axis and the negative y-axis. So plus comma minus. So that is going to be the sign conversion of this. So I'll clearly write. For the first quadrant, it is plus comma plus. For the second quadrant, it is minus comma plus. And if it's a third quadrant, then it is minus comma minus. And in the fourth quadrant, it is plus comma minus. Right? So this is what. Now, I just give some notations for each quadrant. So what is that? I denote this A for first quadrant, and for second quadrant I denote this with an S, and third quadrant I denote this quadrant with a tan, and fourth quadrant I denote this quadrant with this. So in my school days, my teacher used to say all silver teas come, right? Some other terminology to remember. So ASTC. So this ASTC. So what this A denotes here in the first quadrant, all the trigonometric functions are positive. That's what we said. Because both sine and cos are positive here, definitely all the trigonometric functions will be positive when it lies in the first quadrant. When you come to this second quadrant, only sine and its reciprocal. What is this reciprocal of sine? That is cosecant theta. So this cosecant and sine would be positive in between this 90 plus theta and in 90 plus theta and also 180 minus theta in the second quadrant. Now coming to this T, the third quadrant, tan theta and cot theta, right? That is the reciprocal of this cot is nothing but tan is nothing but cot, or reciprocal of cot is nothing but tan. Okay, vice versa. So here this tan and its reciprocal cot would be positive here. And what about this C? C denotes cosine or cos, we can say, and its reciprocal is secant or sec ACC. So that would be positive for these angles. So this is what we infer from this diagram. So when you remember this, it's very, very helpful for you, okay, to proceed further. I'll just give a small example. We'll solve a small example how to find out, and I'll just tell you what are all the fundamentals we need to find out. See, for example, I want to find out the value for sine 330. We know what is sine 270 from the table, that is 0, and we know what is sine 360 from the table, that is also 0. Sorry, this sine 270 is minus 1 and sine 360 is 0. So we know these standard values because these are the values which are nearer to this 330. So we may not be knowing directly what is the value of 330. So I write this sine 330 in two ways. One is I can write the sine 360 minus 30 or sine 270 plus 60 with the known values, right? 270 and 360. I am just writing this. How to find this? See, you have to remember a rule. For 90 and 270, the function remains same. For 180 and 360, sorry, the function will become co-function, right? And for 180 and 360 degree, the function remains the same. So what is this? What is the meaning of this? Why does this function remain same, and what is the function or co-function? We have seen reciprocal function, so you should not be confused about it. The reciprocal of sine is what? The cosecant. The reciprocal of cos is secant. The reciprocal of tan is cot. But the co-function is something different, right? So what is this co-function about? See here, if it is a function, and I'm just writing its corresponding co-function here. If the function is sin theta, then co-function would be cos theta. And if it is cos theta is the function, then the co-function of this cos would be sine. And if it is a tan, then its co-function would be cot. And for cot, the co-function would be tan. And for secant, co-function would be cosecant theta. And for cosecant, the co-function would be secant theta. So luckily, for this tan and cot, we have both the reciprocal function and the co-functions are same, right? So what it means, see here, this 360 takes the value of 360 minus theta. First we will see in which quadrant this 360 minus theta lies. So this 360 minus theta lies in the fourth quadrant. So this lies in the fourth quadrant. Here which function is positive? So first you have to identify the quadrant. Second you have to see the sign conversion. Here only cos and its reciprocal secant are positive. Now here what we have is sine. So it is not lying in the fourth quadrant. So we will denote the sign with the negative value. Suppose you have cos of 360 minus 30. You can put plus sign here, right? Since the fourth quadrant is its cos, the cos has its own quadrant, right? And this is sine or tan or cot or cosecant. We have to put only negative sign. And coming to this third point, for 360 and 180 degree, the function remains same. That means that what is the function here? It is sine. So that remains same. And you have to put whatever the angle you exist, because theta, 360 minus theta, in place of theta what we have here. Now you tell me what is the value for sin 30, as we have seen in the previous table. It is 1 by 2 or 0.5. So we can write sin 30 as 1 by 2. So this minus. So the value for the sin 360 minus 30 is minus 1 by 2. I hope you have understood this step. Okay, sir, this sin 330 can also be written like 270 plus theta. Okay, now how we can find? See, first what is told, we have to see which quadrant this 270 plus theta lies. Right? Which quadrant it lies? It is lying in the fourth quadrant. So we are denoting this as fourth quadrant. And next we have to see what form it is. Whether it is 90 270 or 180 360. So here it is 270. This 270, if 270 or 90 comes, the function becomes co-function. What is the co-function of this sine? As we have seen, the co-function of sine is cos theta. So I am just writing. Okay. This 270 lies in the fourth quadrant. For that I am just that is the sign of this sign would be negative because only cos and its reciprocal are positive. So the sign of the sine function, that is sine conversion of the sine function, is nothing but what? Negative, because it is in the fourth quadrant. That is the first point. Second is 270 and 90 comes, then automatically the function will become co-function. So cos of theta, instead of theta what we have is 60 degree. So what is cos 60? It is equal to sin 30, isn't it? So that's what we have seen. So the value of the sin 330 will become minus 1 by 2. So both the way we can write it, or you can find it. Okay? I hope you have understood these concepts. So the similar thing you have to find out for the other trigonometric functions. Okay? Let me have one more example on this. So I will just erase this. Okay. So I want to find out the value for say some cosecant 210 degree. Okay. So this cosecant 210 degree can be found out by two ways. Similar way like what we have seen, and this 270 is nearer to what? So 210 is nearer to 180 and 270 of the standard values what we have known. So I can write this cosecant 210 as cosecant 180 plus 30 degree or cosecant 270 minus 60 degree. Okay, so now you just see what is our first step. You just see which quadrant this 180 plus theta lies. This 180 plus theta lies in the third quadrant. Okay. Now in the third quadrant, the tan is positive, tan and cot is positive. Here the cosecant is negative, right? So I just write negative. Then 180 comes, the function remains same. For the 180 and 360, the function will be same, right? So what we can write is cosecant. And what is the angle? That is 30 degree. So this is equal to minus cosecant 30 degree. Now you tell me what is cosecant, that is 1 by sine. So cosecant 30 or cosecant theta is equal to 1 by sine theta. Then what is sine 30? That is 1 by 2. So 1 by 2, the reciprocal of 1 by 2 again it becomes minus. This is one way we can find. The other way is 260 minus theta, that is lying in the third quadrant only, where tan and its cot only positive. So I am just putting negative. Then if 270 and 90 comes, for which the function will change to co-function. So what is the co-function of cosecant theta? That is secant theta. So secant of what is theta? That is 60 degree. Understood? Now, what is secant? It can be written as, suppose if you know directly the value of secant, you can easily apply it. Otherwise, from the basics sine, cos and tan you can find out. So this is cos 60. What is cos 60? That is 1 by 2. So reciprocal of this 1 by 2 will be minus 2. This is how we can find out for any values, right? And if the angle is more than 360 degree, then if it is less than 720 degree, you can just divide the function by, suppose for example, say sine of 1110 degree. So here you just divide this 1110 by 360. So how many 360 it comes? So sine 360. So 360 means 720. So when 720 goes, what happens? 9 and say some 390. Okay, so we can go for 3 times. So if it is 3 times, then this becomes 1080. So 1080 means if you subtract it, it will be 30 degree. So now we can write this as sine of 2 into 360 plus 30. That means that for n number of 360 degrees, right, the theta, the value remains same. That's why it will be a periodic function. So this is again equal to sine 30 degree. So that is 1 by 2. So even for higher values, more than 360 degree or 720 degree also, we can find this, right? Thank you. So you just practice on other values. Thank you.